All right, 6.4. So 6.4, we're kind of doing the same stuff that we've been doing all throughout chapter 6. We're dealing with rational exponents again. So if the nth root of a number is a real number, m is an integer. So we've seen this as our exponent. What is the top number? What is it? It's the numerator, but when it's our exponent, what do we do with the top number? Well, what do we do with the bottom number? What's that? The thing that goes out front. So the bottom numbers are index. Then what's the top? The exponent. Remember, the top number stays on top. The bottom numbers are index. That goes out front. So if we had any number with that fraction as an exponent, the bottom, the denominator, goes out front like it does here. And then the exponent can either be an exponent directly on that a inside our radical or outside. So we've done this before. So if I had 2 to the power of 3 over 4, which number is my index? 4. So I would say the 4th root of 2 to the 3rd power, like this. Or you could say the 4th root of 2 to the 3rd power. So that 3 can either be outside or inside. So looking at example 1, what do you think I can do to simplify this? Can I combine them together? Yeah, because my exponents are the same. So when your exponents are the same, we can combine them together to be the same exponent. So this is 7 times 7 to the 1/2 power. What is the 1/2 power? What's my index? 2. So this would be like saying the square root of 7 times 7. What would I do next? I could multiply it. That would give me 49. Then I get 7 and 7. So I don't have to multiply it because it's already broken down for me. So just like before, we don't have to multiply it. I'm circling groups of what here? Groups of 2. Do I have a group of 2? So what comes to the outside? Is anything left on the inside? So our answer is 7. All right, example 2. Can I combine these together? Yep. So this is like saying 5 times 125 to the 1/4 power. Do I have to multiply these together? No, because I'm going to end up breaking it down anyways. What is my index? 4. So where does that go? Out front of my radical. So this is 5 times 125. What do I do next? Break it down. What are 2 factors of 125? 25 and 5. What are 2 factors of 25? 5 and 5. And I'm circling groups of how many? Groups of 4. Do I have a group of 4? So what's going to come to the outside? A 5. Does anything stay on the inside? No. So our answer is 5. All right, example 3. This one looks a little bit different. We have a square root. If I have 7x to the 3rd power, this is like saying 7x times 7x times 7x. So I'm going to put all my numbers together. So I have 7 times 7 times 7, and x times x times x. What should I do next? Do I have to multiply them? No. So what can I do? group them. So I'm circling how many? How many of a kind? 2 of a kind. So what would I circle? 2 sevens and 2 x's. So what comes to the outside? 7x. And what stays on the inside? 7x. And that's our answer. All right, another way we can do this one, so I'm just going to do it on the side here. So we have the square root of 7x cubed. Another way we can do this, when we have a number and an exponent raised to a power, since they're in parentheses, that exponent goes to both of these. So this is like saying 7 to the 3rd power and x to the 3rd power. But you could do it this way too. So when you have 2 things that are raised to a power, you can distribute that power. So 7 to the 3rd power is like saying 7 times 7 times 7. And x to the 3rd power is like saying x times x times x, which is the same thing here. So it's just a different way of starting it. On the next page, so this is the same question, but instead of putting that 3rd power on the inside, they put it on the outside, which means the same thing. So this is like saying the square root of 7x times the square root of 7x times the square root of 7x. Because we have 3 of the square root of 7x. Can I combine these together? Yeah, they have the same index, so I can combine them. So it's like saying the square root of 7x times 7x times 7x, which is the same thing that we just did on the last page. So it doesn't matter if our exponent's inside or outside, if it's up top. Because remember, the last one had it here. We'll end up with the same thing. So here I'm going to put the numbers together. So this is 7 times 7 times 7, and x times x times x. So what would I circle here? 2 sevens and 2 x's. What comes to the outside? 7x. What stays on the inside? 7x. So it's the same question that we had on the last page. All right, so this one is kind of the most important. I would say a lot of the questions from the homework look like this. So we have a number and a variable raised to this exponent. So what I want to do is distribute that exponent to both the number and the variable. So I'm going to treat it as 2 different problems. I'm going to focus on the number first. So I have 64 raised to the power of 3 over 2, and n to the 4th power raised to the power of 3 over 2. So I'm just going to deal with the number first, just this one first. What is my index? My index is 2. So what do I do with that? What do I do with the index? Put it out front. So then this is 64 to the 3rd power. Do I have to multiply 64 times 64 times 64? No. We'll just write it out so we know how many we have. What are 2 factors of 64? 8 and 8. 8 and 8. 8 and 8. What should I do next? Circle. I can circle them because I have pairs. I'm circling how many of a kind here? Circle 2 of a kind. So I have 2, 2, and 2. So what comes to the outside? 8 times 8 times 8. So these we actually have to multiply because it'll give us our answer. So what's 8 times 8? 64, and then we'll multiply another 8 to it. So what's 4 times 8? 32. And 8 times 6? 48 plus 3? 48 plus 3? 51. So this gives us 512. So that's just the number part. Now we're going to look at the variable part here. So we're going to do this part. So what do you think I can do when I have two exponents right next to each other? What do I do with these? A power raised to a power. Multiply it. So I multiply these together. So this is like saying 4 over 1. How do I multiply fractions? Just multiply straight across. So this is, what's 4 times 3? 12. And 1 times 2? 2. Can I simplify 12 over 2? What's 12 divided by 2? 6. So this would be n to the 6th power. So we just have to make sure we put that with our answer down here. So our answer is 512 times n to the 6th power. So when you have questions like this, do them separately. Do the number first and then the variable. But the most important thing is you make sure that that exponent gets distributed to both. So don't forget to distribute it to the number and to the variable. It has to go to both things. All right, let's look at the next. So here I just have a variable raised to an exponent raised to an exponent. So what do you think I can do? Multiply them, just like I did in the last one. This is like 8 over 1 times 1 over 2. How do I multiply fractions? Multiply straight across. So the tops together and the bottoms together. What's 8 times 1? 8. And 1 times 2? Can I simplify 8 over 2? Yes. What does it simplify to? 4. So what would my answer be? N to the 4th power. Another way we can do this, so there's more than one way we can solve, is I have n to the 8th power. So that is 8 n's. 1, 2, 3, 4, 5, 6, 7, 8. What's my index here? 2 is the index. So I circle what? Groups of how many? Groups of 2. How many circles do I have? 4. So that's how we get that. So you can do it either way. You can multiply when you have an exponent raised to an exponent, or you could solve it the same way that we have been. Write them all out, circle your pairs. Yes.